function f of x equals x plus 7 is differentiable everywhere or not. And this is question 7 of test 2. So first thing we have to do is graph our equation. Right? Where I'm going to start is at negative 7. So we're going to make this point here, negative 7. All right, when x equals negative 7, y equals 0. When x equals negative 8, y equals 1. When x equals negative 9, y equals 2. Let's draw these points right here. Right here, right here. So we see that when the graph is going to the left and it runs over 1 and it rises 1, the slope right here is m equals negative 1 because it is going to the left in a negative direction, and the rise over run of 1 over 1 lets me know that m is equal to 1. So when the function is going to the left, our slope is negative 1. Now, when x equals negative 6, y equals 1. When x equals negative 5, y equals 2. So let's draw our graph going in this direction. And once again, my rise over run, it runs over 1 and it rises 1. And since it's going to the right in a positive direction, my slope is going to be m equal 1. So, is the function differentiable? The function is differentiable everywhere except at x equals negative 7, because there cannot be two slopes. That is where our slope of 1 and our slope of negative 1 meet. Two slopes cannot exist at one point. So the function is differentiable everywhere except at x equals negative 7. Thank you. All right, question 9 is asking us to find and graph f prime of x for our graph of f of x, which, let's draw our first original graph. Its y-intercept is negative 4, its x-intercept is 4. All right. If we use our rise over run to find our slope, since we see there is a 4 right here and a 4 right there, we identify that our slope is equal to 1. M equal 1. All right. We also can see that our equation is y equal x minus 4. That is the equation of our graph, y equal x minus 4. So now simply to find and graph f prime of x, we just have to find y prime, which x, the differential of x is 1, and negative 4 is a whole number, it turns to 0, it does not exist, so y prime equal 1. Now, to graph this equation, we simply just draw our x-axis and draw one straight line going through the y-intercept at the point 0, 1. And the whole graph is up 1 in a straight line forever. And that is how you graph f prime of x for this equation, right? Or for this graph right here. Thank you. So now, our question 10 is asking us, given the graph of f, sketch the graph of f prime. This is super similar to our last question. So first, let's graph our original graph. It is going to have its x-intercept at 4. And it's going to go up that way and up that way, with its y-intercept being 4. So by looking at the graph, we see that when it runs over 4 and it rises 4, we can identify the slope is m equal -1. Right? Just like our previous equation, our slope right here on this side is m equal -1. And on this side as well, right, we identify that it runs over 4 and it rises 4. So as well, get a slope of m equal 1, not -1, of 1. Now that we've identified our slopes and we know that our point 4 is going to be constant, we're going to draw the second graph of f prime x. Right? We still have our point 4, but the difference is we're going to have one line to the right up 1 at the intersection 1, y-intercept 1, and another one at y-intercept -1 going this way. That is down -1. The one right here is representing the slope of this line right here, and the one right here is representing the slope of that equation right there. So at the point x equal 4, the slope does not exist. X equal 4, the slope does not exist. And this is how you draw the graph of f prime of x. We find the slope, we have our x-intercept, we have our 4, and we simply just have to find our slope of our original graph. Thank you. So question 6. Question 6 is asking us to find the tangent line of f of x equals 3x cubed minus 10 at the points 2, 14. So first we're going to visualize our graph so we have an idea of what's going on. So we know that the graph is, or our function is cubed, so it's going to go somewhat like this. We're going to draw our x or y-intercept right here at -10, 2 right here, and our point 2, 14, just like that. Now we have to find f prime of x to find the tangent line. So we have our original equation, y equals 3x cubed minus 10. And to find the slope, we're going to have to find the y prime of this equation right here. And we're going to use the power rule. And the power rule states that yx, xn, that's our original equation, y prime of x is going to equal n of x n minus 1. nx n minus 1. So we simply just put these variables into our equation, and we get y prime equals 3 times 3. We move our exponent to the front, times it by the original number that was at the front, x, 3 minus 1 minus 0, because the derivative of a whole number is going to be 0. So y prime equals 9x squared. Now, all we simply do is grab the original 2 that was given to us from our original point. So if x equals 2, and we input this into 9x squared, we receive the number 36, because 9 times 4 equals 36. And that is our slope. That is the slope at the point 2, 14. Now, we simply just put it into our equation formula, which is going to be y equal y1 plus m x minus x1. Right, we grab our original y from the original point given to us, which is 14, plus the slope that we just found, 36, parentheses x minus 2, which was the x given to us at the original point. So we distribute 36, y equals 14 plus 36x minus 72, and if we further break this down, we get y equal 36x minus 58. And that is the equation of the tangent line to the graph not to the graph, to the function f of x equals 3x cubed minus 10 at the point 2 comma 14. This is our answer. Y equal 36x minus 58. Thank you. All right, next up is question 7. Question 7 is asking us, oh, I'm sorry. This is question 9. Question 9 is asking us to determine at the points at which the graph f of x equals x to the power of 4 minus 2x squared plus 3 has a horizontal tangent line. So, first thing we gotta do is find f prime of x. We use the power rule to find the derivatives of these numbers. x4, carry the 4 across, 4 minus 1 is 3. We get 4x cubed. 2x squared is going to become minus 4x, right? 2 is taken to the front. 2 times 2 is 4. 2 minus 1 is 1. And then since 3 is a whole number, it has no exponents, it turns into 0. We simply just don't include that. Now, this equation right here can get further broken down into f prime of x equals 4x x squared minus 1. And to find the horizontal tangent lines, we have to find the numbers that make this equation right here equal to 0. So, let's draw our graph. Our graph is going to look just like this. We have to find the horizontal tangent lines. Now, our equation can get further broken down into 4x, x minus 1, x plus 1. And now we have to find the variables that make this equal to 0. So, obviously, if we input 0 into this equation, we are going to get 0. So when x equals 0, there is a horizontal tangent line. As well as when we input the number 1, right? If we input 1 right here, 1 minus 1 is 0. 0 times the rest of the function is going to make everything else equal to 0. So when x equals 1, we also have a horizontal tangent line. Or we also make the equation equal to 0. Same thing goes right here. If we input negative 1 and make that number 0, 0 times the rest of the function is going to make everything else equal 0. So when x equals negative 1, the function also is 0. So now with these numbers, we can determine that at the points x equals 0, x equal 1, and x equal negative 1, there's going to be a horizontal tangent line. There we go. Thank you. All right, next up is question 8. Question 8 is asking us to find the derivative of the trigonometric function f of x equals x squared tangent x. To find the derivative of this, we're going to have to use something called the product rule. And the product rule states the derivative respect to x, f of x times g of x, is equal to f prime x times g of x plus f of x g prime x times g prime x. So if we look at our original equation, x squared is our f of x times tangent x, and tangent x is our g of x. We know that the f prime of x squared is 2x, and the g prime of x of tangent x is going to be 1 over cosine squared x. Now, we just simply input this into our product rule equation, and we're going to get 2x tangent x plus x squared 1 over cosine squared x. And that is our final equation. That is the derivative of the trigonometric function x squared tangent x. To solve this, we simply just input our values into the product rule to get 2x tangent x plus x squared 1 over cosine squared x. And this is our final answer. That is the derivative using the product rule. Thank you. Now we are on question 11. Question 11 is asking us to find the second derivative of f of x equals x over x minus 1. To find this, we're going to have to use the quotient rule. And the quotient rule states that f prime of x equals g prime x times h of x minus, and that's where it differentiates from the product rule, gx times h prime of x over hx squared. So now we just simply have to input our values. Our g of x is x, and our h of x is x minus 1. G prime of x is equal to 1, and h prime of x is equal to 1 minus 0. So now we just simply input all of our variables, and we get f prime of x equals 1 times x minus 1 minus x times 1 minus 0 over x minus 1 squared. If we further break down this equation, we get f prime of x equal x minus 1 minus x minus 1 squared. F prime of x equals negative 1 over x minus 1 squared. And that is the first derivative. Now, to find the second derivative, we just have to do the quotient rule again, right? So for the second derivative with respect to x, the derivative of negative 1 is 0, so it's going to be 0 times x minus 1 squared minus 1 times the derivative of x minus 1 to the power of 2. Take the 2 across, it's going to be 2x minus 1 over x minus 1 squared. Now, if we break down this function, 0 times x minus 1 squared is obviously going to be 0. So we get x equal to x minus 1 over x, oh, sorry, there we go, it gets squared twice. X minus 1 to the power of 4. Now, we continue to break down this equation. X minus 1, they share the same, those two are the same number. So we get second derivative is equal to 2 over x minus 1 cubed. And that is how you find the second derivative. We use the quotient rule twice. And that is the second derivative of f of x equals x over x minus 1. Thank you. All right, next up, we're going to be tackling question 5. Question 5 is asking us to find the equation of the tangent line to the graph f of x equals 9 minus x squared to the power of 2 over 3 at the point 1, 4. Right, into this, we're going to have to use the chain rule. And the chain rule states that f of x is equal to d du f of u times d of u over d of x. Our f of u for this equation is u 2/3. Our u is equal to 9 minus x squared. D of u over d of x of this equation is equal to 2x or negative 2x, and df over du of this equation is equal to 2 over 3 u minus 1 over 3. So now we simply just input our variables. So if d of f over d of x equals d of f over d of u times du over d of x, we're going to get 2 over 3u power 1 times negative 2x, which equals 2 over 3, 9 minus x squared, minus 1 over 3, negative 2x, and we get f prime of x equal negative 4x over 3, 9 minus x squared to the power 1 over 3. And that is the equation, or that is the derivative of our original equation. F prime of x is equal to negative 4x over 3, 9 minus x squared to the power 1 over 3. Now, to find the equation of the tangent line at that certain point, we're going to have to input x equal 1, or 1 as our x, because that is the point that was given to us at the beginning of the equation. So f prime of x, if you input 1, you're going to get negative 4 times 1 over 3 cubed times 8 squared, which is equal to negative 4 over 6, which equals negative 2 over 3. And that is your slope. That is the slope of the equation. Now we have to put it into our equation formula, which is equal to y equal y1 plus m x minus x1. So let's input our variables. We have 4 right here. That is the y that was given to us at our original point, plus the slope that we just found out, x minus x1. Our original x was 1. So we just do a little algebra. We distribute our properties. We get y equal 4 minus 2 over 3x plus 2 over 3. And we finally get y equal negative 2 over 3x plus 4, 2 over 3. And that is the equation of the tangent line to that original function at the point 1 over 4. It is going to be y equal negative 2 over 3x plus 4, 2, 3. Thank you. Next up is question 9, and is asking us to find the derivative of the function f of x equals 5 over x cubed minus 2 at the point negative 2 comma negative 1/2. So to do this equation, we're going to use the quotient rule once again. So f prime of x equals the derivative of 5 is 0 times x cubed minus 2 minus 5 times the derivative of x cubed minus 2 is 3x squared over x cubed minus 2 squared. Now, we continue to break down this equation, do some algebra. We get negative 15x squared over x cubed minus 2 squared. Now, it's asking us to find the derivative of the function at the point negative 2 comma negative 1/2. So we have to input our negative 2 as our x in our new function. So f prime negative 2 equal to negative 15, negative 2, 2, negative 2 cubed minus 2 squared. If we input this into our calculators, we do a little algebra, we receive the number minus 60 over 100, or negative 6 over 10. And that would be our slope. That would be our slope at that point. So this right here would be the derivative of the function at the points -2 minus half. This would be our slope. So our final answer is going to be right here. Thank you. And finally, we are on to question 51, which is asking us the gross annual earnings of a certain company were AT equal 0.1 t squared plus 10t plus $20,000 t years after its formation in 2008. And our question is, at what rate were the gross annual earnings of the company growing with respect to time in 2012? So our t is equal to 4 because 2012 is 4 years after 2008. And we have to find the derivative of our function. So derivative of 0.1 t squared is going to become, this is going to become 2t. Take the 2 across. 2 times 1 is 2. 2 minus 1 at the top for the exponent is 1, so we get 2t. The derivative of 10t is simply just going to turn into 10. And the derivative of 20 is just simply equal to 0. So we input our values, 2t, or 0.2t, sorry, 0.2t plus 10. And now we input our 4. Right? If we make t equal to 4, we get 0.8 plus 10 and get the final number of $10.8 per year. And obviously it's in thousands as our original equation stated. So our final answer will be 10.8. We solve this by finding the derivative of the original equation and then inputting 4 as our t because it is t years after the formation and it was 4 years after. So our final answer is going to be $10.8 in thousands per year. Thank you.